Welcome to ACE Academic Tutors. Today we're going to cover a topic that's a very fundamental topic in GCSE physics. It outlines how we see quantities, which is essentially how we describe the physical world around us. The specific topic of interest today is the difference between vector and scalar quantities. So let's have a look at that. Okay, so we'll start off with the easier one, which is a scalar quantity. So scalar quantities are quantities that have magnitude only, which is essentially the size of something. Examples of these quantities are outlined below. So common examples are temperature, which is like you could say something like 25 degrees Celsius. It doesn't outline any kind of direction associated with it, so we don't really talk about the direction of the temperature itself. Or if we talk about mass, for example, we don't say mass has a particular direction, right? So mass of 5 kilograms or temperature of 25 degrees Celsius, completely tells the story itself of what you're talking about. Same thing applies to something like time of 10 seconds or speed of 30 meters per second, or a distance of 100 meters. Now, all these quantities have one essential component, which is the magnitude meaning size, right? So scalars tell you how much of something you have, but it doesn't give you a particular direction of which way, right? So moving on to vector quantities. Now, vector quantities also have magnitude, but it also has an associated direction with them. So quantities like displacement, which is essentially what you would have in the scalar term, you'd have a distance, but if you add a direction to it, we call that displacement. And another example of vector quantity is velocity, which is essentially speed with a given direction. Force, acceleration, or momentum also tend to be vector quantities because they all have associated directions with them. Now, how do we represent these vector quantities? We represent them using arrows. So a typical representation of an arrow would be the length representing the magnitude or the size of something. So a larger arrow represents a larger vector quantity, and the direction of the arrow represents the direction of that quantity as well. So key differences between vector and scalar quantities: vectors will have magnitude and direction, and scalars will have magnitude only, whereas a vector quantity will have associated addition rules. So if you're trying to add certain quantities together, so you can't do that for vector quantities, but you can do them for scalar quantities. For example, if you have a distance of 5 kilometers that you've walked, and you've walked another 3 kilometers after that, you could say you've walked a total distance of 8 kilometers in total. You can't do the same for vector quantities because the associated directions tend to make the calculation a little bit more complicated. So for example, if you walked 5 kilometers east and then 3 kilometers north, it will not be the same as walking 8 kilometers in a given direction, right? So for scalar quantities, there's no direction needed, but for vector quantities, direction is essential. So some real world examples: let's say you're walking from home to school, and the path that you took was 500 meters away, right? So the total distance you would have traveled from home to school is 500 meters, but the displacement between the home and the school is basically a straight line that takes you from your house to your school. This might not be the same as your distance because this is a direct line from your house to your school. So the exact distance between your house and school, which is drawn by a straight line, is what would represent as a displacement, whereas the path that you might take, which may not be straight, right, will be what your total distance traveled to school is. Okay, now adding vectors. So this is why I sort of briefly mentioned earlier, if you want to add vectors together, you can use basically Pythagoras' theorem, which from maths essentially. So in this case, you have you're walking 3 kilometers east and then 4 kilometers north. If you started on the bottom left of this triangle, and the final sort of vector that you've traveled would be 5 meters. So the way you do this calculation is you do Pythagoras' theorem. So 3 squared plus 4 squared, so that's 9 plus 16 would give you 25. You'd square root that to get 5 meters northeast. So this is essentially a 3, 4, 5 triangle where you're traveling 3 meters east, 4 meters north, which is essentially a total displacement of 5 meters northeast from your starting location. Hopefully that's clear. Right, so this is a quick quiz. If you've got temperature at 20 degrees, or this is essentially a scalar quantity because we don't associate a direction with that. Speed of 60 miles per hour. Again, there's no associated direction with that, so that's another scalar quantity for number 3. Number 2, a force which is 15 Newton upwards. Because you've got direction there along with your magnitude, we call this a vector quantity. And the last one, a velocity of 10 meters per second west, would be a vector quantity. So hopefully that's clear, and we've got the key differences between vector and scalar quantities sort of cleared up. In summary, basically, scalars tend to have magnitudes only. Vectors will have magnitude and direction. If you'd want to learn more about this topic, you can reach us on ACE Academic Tutors. Thank you.